Welcome you all. I am Dr. Jahan, Associate Professor, Electronics and Communication Department from Rohini College of Engineering and Technology, Kanyakumari. So this video I have discussed about ADA wireless sensor networks, black hole attack and its countermeasures. Black hole attacks occurs under DOS, denial of service attack in the network layer of OSI model. In this kind of attacks, the malicious node forgery other nodes by announcing a shortest false route to the destination, then attracts additional traffic and prompt continuously the packets. During data transmission, the source node sends a route request message to all nodes, including malicious node. Given that a malicious node may become active by receiving or request message and replies using route reply message. It attracts additional traffic by falsely claiming the shortest route to the destination. This causes blocking and increasing the energy consumption in each node, leading to the formation of routing holes which disturb or stop the network functionality. The below figure illustrates the black hole attack. While the source node A broadcasts an or request message to discover the route for sending packets to destination node C. An or request broadcast from node A is received by neighboring nodes B, D, and the malicious node E. The or reply message sent by the malicious attacker node E is the first message reaching the source node. This last updates its routing table for the new route to the intended node destination, discarding any request reply message from other neighboring nodes, including the actual node destination, and starts sending the buffer data packets immediately. In the same time, the backward node drops all coming data packets rather than forwarding. Figure 4.2 backward attack semantic illustration using record request and reply request reply packets. Black hole attack source. Routing access restriction. Routing may be one of the most attractive attack targets in wireless sensor network. If we can exclude attackers from participating in the routing process, that is, restrict them from accessing routing, a large number of attacks in the network layer will be prevented or alleviated. Multipath routing is one of the methods to reduce the effectiveness of attacks launched by attackers on routing paths. In these schemes, packets are routed through multiple paths. Even if the attacker on one of the paths dives down the path, the routing is not necessarily broken as other paths still exist. This alleviates the impact of routing attacks, although does not prevent this attack. A general way is to use authentication methods. With authentication, it can be easily determined whether a sensor can participate in routing or not. Authentication can be either end-to-end or hope-to-hope. In end-to-end authentication, the source and destination share some secret and can thus verify each other. When a node receives a routing update, it always verifies the sender of the update before accepting the update. In hope-to-hope authentication, each message in transmission is authenticated hope by hope. Therefore, the trust between the source and the destination is built upon the trust on all the intermediate nodes in the path. Data are authenticated hope by hope between associated nodes until they reach the base station. Hope-to-hope authentication can be combined with multipath routing. This path can be physical, meaning that messages are routed through multiple physically different communication. False routing information detection. Sometimes attackers do have chances to send false routing information into the network. Example, during route discovery stages, if the false information does not lead to network failure, such as broken routes, we really cannot do much about it. Otherwise, we can apply the idea of misbehavior detection method. For example, watchdogs or IDS intrusion detection system may find that some node fails to route messages along the routing path due to wrong information it keeps. This anomaly of route failure may trigger out an alarm. Nodes can start to trace the source of false routing information. The reputation can also be maintained depending on whether nodes are providing valid routing information. Flooding attack and its countermeasures. Many protocols require nodes to broadcast hollow packets to announce themselves to their neighbors, and a node receiving such packet may assume that it is within normal radio range of the sender. These assumptions may be false. A laptop class attacker broadcasting routing or other information with large enough transmission power could convince every node in the network that the adversary is its neighbor. For example, an adversary advertising a very high quality route to the base station to every node in the network could cause a large number of nodes to attempt to use this route. But those nodes sufficiently far away from the adversary would be sending packets into oblivion. The network is left in state of confusion. Source protocol and architecture of wireless internet using secret keys method. In multipath, multi-base station data forwarding technique, each sensor node maintains number of different secrets key in the multiple tree. Sensor node can forward its sense data to multiple routes by using these secrets. There are multiple base stations in the network that have control over specific number of nodes, and also there are common means of communication among base stations. Each base station has all secrets that are shared by all the sensor nodes covered by it according to the key assignment protocol. Using threshold method. A threshold based solution is used to defend against flooding attacks in wireless sensor network. The mobile nodes use a threshold value to check whether its neighbors are intruders or not. When the number of route packets, when the number of route request packets broadcasted by a node exceeds the predefined threshold value, it is treated as an intruder and the node starts providing services to the intruder.